In this video, we're going to look at transformations with trig functions, and we're going to start from the basics, and hopefully you remember this general formula from grade 11. In this formula, I'm going to start with the right-hand side. Hopefully you remember this plus c is our vertical shift, right? Similar to all the other types of functions that we study as well. And in the brackets, once it's been factored, this d value is our horizontal shift. Okay, similar to other functions that you've done. Also, we know that A is what we like to call maybe our stretch or our vertical stretch if you like. Now, specifically for trig functions though, this does mean the amplitude as well, and we'll review that in just a second. And the one that's the most different is this K value right here, okay, which for trig functions helps us to determine our period. So just a couple of examples here just so that you can see it. Okay, in this first one, you can see it has a stretch of 3. Now it also has a reflection, which we'll deal with separately. The K value is a half. Note it has to be factored right here. This is shifting right pi over 6 and up 3. Okay, and in the second example, it's a cosine curve instead. It's got an amplitude of 2. It has a K value of 4. It's shifting left a half and down 1. Okay, so let's look at these characteristics and we'll talk about some specific examples and then we'll look at how to apply them. Okay, so the first one we're going to talk about is our amplitude. Okay, so the amplitude as we discussed above is A, but we're actually going to say that it's the absolute value of A is the amplitude, because amplitude represents a distance. Okay, so we would say that if A is less than 0, then that means we have a reflection over the x-axis. Okay, so for example, if we have something like y equals negative 6 sine x, we say that A equals 6, but it has a reflection. Okay, so amplitude is always the positive. Okay, similarly, if we have something like y equals 1/2 cos x, we would say that the amplitude equals a half. Okay, so that's the amplitude. Next is our period, okay, and we can determine the period of the function from the K value. So the period, or you can use P, is found by taking 2 pi and dividing it by the absolute value of K. Okay, and again, 2 pi because the regular period for a sine wave or a cosine wave is 2 pi, as you saw in the previous lesson. Okay, so let me give you an example for this one. Let's say we have something like sine 2x. Then we would say that the period equals 2 pi divided by k, which in this case is 2. So the period is pi. Okay, so this is like a squished, the whole entire sine wave would be complete within pi. Okay, let's look at a more complicated example. Okay, something like y equals 3 cos 1/4 x plus 1. Okay, here to get our period, it would be 2 pi divided by k, which k is 1/4. And 2 pi divided by 1/4 is 8 pi. So this is a super stretched out cosine wave. Okay, so we'll do lots of practice with that. Vertical translation is much more simple. If c is positive, we know that that means up. And if c is negative, we know that means down. Okay, so for example, if we have something like y equals negative 6 sine x minus 7, we know that that's going to be shifted down 7. Okay, and similarly, the horizontal translation, I'm going to write it like this so that it makes sense, so there's no confusion. If it's x minus d, then that means we're going to go right d. If we have something like this, x plus a value, then we're going to go left d. Okay, let me give you some examples. Let's suppose we have something like y equals 4 cos x plus pi over 6 minus 8. So this one would mean left pi over 6. Okay, if we had something like y equals 2 cos 1/2 x minus 12 plus 1. I'm trying to trick you here. Be careful. You have to factor that. So you would factor out the half, and you would end up with x minus 24. And this would mean to the right 24. Okay, so we'll watch out for that. Let's see if we can apply some of that knowledge. Okay, so before we get into graphing, we're just going to look at the idea of stating all of these transformations. So here's a warm-up, or if you like, our first example right here. Y equals -3 sine. It's factored already for you, and plus 3. So if you can just pause the video and try to pull out the information, that would be a good test of your knowledge so far. Okay, so amplitude is 3. Right, that comes from that value right there at the front. Now, note it does have a reflection, so the idea in this table is that you would just say yes, it has a reflection, or the x-axis, or no. Okay, our period is a little more complicated. To get our period, we're going to take 2 pi. We're going to divide by the k value, which is half, that has been factored out already, which gives us a period of 4 pi. 2 pi divided by half equals 4 pi. Okay, phase shift is another way of saying the horizontal shift. Okay, either or, doesn't matter. Again, make sure it's already factored, but this one is right pi over 6. Okay, you can use an L. You can use arrows or L's and R's, it doesn't matter. And our vertical shift, we know from the end, is our plus 3, so it's up 3. Again, you can use arrows or up or down, whatever you like there. Okay, so take a look at that first one right there, that example 1. Hopefully you can see that the idea with this one, the thing that you have to watch out for is you must factor it first. Okay, so this really is 2 sine. We're going to factor out the k value, the value in the front there. You're going to need square brackets, so it's going to be 2 bracket x minus, you tell me what goes in that other spot here, and then the minus 1. Okay, so when we factor a 2 out of that, we're thinking of pi over 2 divided by 2. That means this becomes pi over 4. Okay, and hopefully you can see how you're going to get your phase or your horizontal shift wrong if you do not factor first. Okay, so now that we've got it factored, pause the video, try to fill in the table by yourself. Okay, amplitude is 2. There is no reflection over the x-axis. Okay, period is 2 pi divided by k, which is 2. So the period is pi. Phase shift is right pi over 4. And the vertical shift is down 1. Okay, so you're going to finish, you're going to work on this table for a little while before we get into actually graphing.